Hello, hello, and today we are continuing talking about how to describe data, and in order to do that, we need to know about how to find outliers. So again, you will need a calculator today, so if you have that, please go get it out. And join me on page 4. Okay, so what is an outlier? An outlier is a value that is outside of an overall pattern. It's far away from the rest of the data. If you want to maybe throw your own word on there, I want you to maybe put extreme, like it's not by everything else. And in order to tell if something's far away, there's kind of two train of thoughts that we can be working with. You can say, all right, well, think about the median. You have your median that kind of describes where an average number is away. What we're going to do is we're going to make an upper bound to some point, an upper bound. And we're going to say, hey, if anything is beyond the upper bound, like if anything is that beyond that, that would be considered an outlier. And then we're going to also have a lower bound. And if anything is beyond that, we would consider that extreme, and we would say that we have an outlier. So there's kind of two ways to think about that. You could also do it with the mean. The mean's another way to think about the average. And we are also going to have an upper bound when we're thinking about the mean. Like there's a certain number that's kind of far away from the mean. Anything beyond there is an outlier. And we're also going to have a lower bound. And anything that's, lower than our lower bound, we would consider an extreme. We would consider it an outlier. So today we're going to talk about how to calculate those bounds. So in order to calculate the bounds for, the option 1 is really when you have access to the median, it's easily there. To calculate the bounds, you are going to have your median number, and remember we talked about those quartiles, so you would have your lower quartile is the lower 25% of the data, and then the quartile 3 is like the upper 25%. If you take the IQR and you add a little bit on or subtract a little bit from both of those regions, those would get you your bounds, and you're saying anything outside of that number is considered an outlier. Versus for option 2 would be if you maybe had more access to your the average, you would calculate the bounds that way by saying, okay, my lower cutoff is if I'm 2 standard deviations away from the mean, right? On the lower side, or if I'm 2 standard deviations away from the mean on the upper side. We would consider those bounds. Something to realize here is that the bounds are not outliers themselves. It's anything beyond the bounds are outliers. So let's take a moment. Both of these are not perfect. They both get you in the general ballpark for what is considered, far away. So let's start with option 1. We're going to work with the same data set for both of these. Option 1 says, okay, let's use the median sort of way. So really quickly, we would actually have to go find the median. Okay, so I found the median. Good, because for our IQR, in order to find that is Q3 minus Q1. So there's my formula. I'd have to plug in the numbers and get the answer for what the IQR is first, right? So I'm going to go through here and see if I can find those things. So looks like between here, 8 would be Q1. And then over here, I would need to figure out what's between 16 and 20, that would be 18. So 18 is Q3. So when I subtract those, my IQR is 10. So now I can work over here on finding my lower bound. So my lower bound is taking Q1. Q1 was 8. And we need to find out, we need to take our IQR and just put a little bit more than that, 1.5 on both sides. So we do 1.5 times the IQR, which is 10. and that is going to give me -7. So that's my lower bound. If anything is past -7, that is considered an outlier. Then my upper bound over here would be if I take Q3 and I just go a little bit further, right? So 1.5 plus my QR, which is 10. And, I don't know why I put Q3 like that. Maybe. We know Q3 is 18. Right, so if we do that, that'll end up coming out to be 33. So if anything is beyond 33, is an outlier. So let's come back here and look at our data set really fast. Do we have any data values that are less than -7? No, there's nothing less than -7. But if I come over here and look, is there anything above 33? Well, there's 33, but this is my upper bound. It is not an outlier. Anything beyond it is. So I would get to say that 34 is an outlier. So I found something that is farther. It is beyond my bound. It looks pretty good. And if we made a display, it would be easier to see that. All right, so that is one example. The other example is easy to work with if you have your mean. Okay, so I would say the one that we're probably going to use more often and that is easier to use is probably option 1. I would say maybe memorize. You have to memorize one of these things, so I don't know, pick one, but you need to memorize something of this. So let's practice putting this in our calculator, because to get the mean and standard deviation of a data is kind of a pain in the rear end. So, calculators out. Let's see, where the heck? I have all sorts of stuff going on. Okay, so the first thing that we are going to do here is we need to put our data in the calculator. So go to Stat and click Edit. This is not the right data set, so in order to clear out an old data set, arrow up and click Clear and Enter. And now we're going to put our data in. I've got 0, 0, 7. The way that you learn how to do this is practice by doing. There are so many people that get clueless on how to do this because they just watch me do it and they never do it for themselves. The only way I figured this out was by doing it myself. Okay, it's probably good to check to make sure that you have the right number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And there are 13 of them. And so now we're trying to calculate stuff. So if you go to Stat, we are telling our calculator to calculate stuff for me. So I'm going to go over to Calc and hit one of our stats. I typed everything in L1. If you typed it in L2 or L3, you would put that there. And then we're just going to calculate it. And oh my gosh, if you look, they come up with the average. And if you even scroll down, look, it comes up with your Q1 and Q3 for you. It didn't even have to do that. It tells you your median. So if you really wanted to use your calculator for that, you totally could. But what we were interested in was the mean, which it appears the mean is 13. And then the standard deviation is 10.56. So we're going to come back over here. We have the mean was X bar is 13, and then the standard deviation from our calculator is 10.56. I'm just rounding up. So now it's up for us to find our bounds again. So rolling with this, I need to take my mean and find out what's a little bit far away from that. 2 times the standard deviation. Why do I keep doing that? I keep writing the symbol again, like I'm losing it. 13 minus a little bit, and that is going to come up with -8.12 as my lower bound. And then if we did our upper bound, that is saying, okay, take 13 and then just put a little bit further. So that would be 2 times the standard deviation again. And that would get us 34.12. So, looking at this method, again, the bounds, I don't know how to say it, bounds are not outliers. They themselves are not outliers. It's the stuff that is beyond the bounds. So, looking at this method, do we have anything that's less than negative 18? Negative 8. No, there's nothing less than negative 8 over here. And then do we have anything that's greater than 42 or 43? Well, I just said that wrong 3 times. 34. No, there's nothing greater than that. So by this method, there are no outliers. According to those different methods, you might be thinking, okay, that's kind of crazy. Like, why am I doing the same thing and it's giving me different answers? Well, they are a little bit different. And again, if you notice, the upper bound for the other one was 33, and the upper bound for this one is 34. I mean, that's pretty close. These are also pretty close. So again, we are looking, these are just kind of approximations. We're looking for extremes. And so since they're kind of close, we're just looking for anything that's super far away. It's probably not that far away if we're, I guess, like, I don't know, 34 is probably not that far away, so, but we're still going to work with it. So anyways, pick your favorite option and memorize it. Just think it's what we have plus a little bit more would be those bounds. I think this one's probably the better one to keep track of. You got this.
Sorry. If you are given information on the median and the quartiles, that is when you would want to use option 1. Option 2 is when you are given stuff about the mean and the standard deviation. It might be easier to use option 2. And I just wanted to show you what we were doing in action with these formulas. So for option 1, you found the IQR, which is in blue here, right? You found the IQR. And then what you did is you added to those quartiles, you added the IQR plus a little bit. And then those gave you your cutoff points. So anything outside of that blue and yellow region, those were your outliers. Whereas in option 2, we had the mean, right, the average, and we said, okay, if we take the standard deviation, which remember what the standard deviation is. The standard deviation is pretty much just, how far is a typical value away from the mean. If we take 2 of those distances, if you are outside that, then you are too far gone, and that is when we call you an outlier. So I just wanted to kind of visually show you what was happening with these 2 and when it would be beneficial to use option 1 and when it would be beneficial to use option 2. All right. How do I end this?